So yes, we are recorded. Okay. So welcome you all to this live session on numerical methods, problem solving session on numerical methods. This is a week 7 we are talking about. We are in the modules. It's actually a one module, regression and interpolation. First we started. So before going into the topic, let me introduce you to myself to you. I am Rigved Saman, currently working as a PhD student at IIT Guwahati. I've been awarded Prime Minister Research Fellowship, and pertaining to that, I'm working in the field of lithium-ion batteries, and I'm using these techniques for my research purpose. So the somewhat knowledge from using the techniques will be helpful for you here. So I am a teaching assistant for this course, and I would be interacting to you all in the live sessions. We have been doing it for the last 5-6 weeks, and we are in the middle of the course. I urge everyone to join this session if they are not. You guys are going at offline and doing the video lectures. But if you have any doubts, you just can post it on the Google forum, and we will try to address them here. So we are in the week 7. Yesterday only we talked about the regression. So in regression we saw how to tackle. We started with a simple linear regression, and we saw how to tackle a problem where there are two different variables at play using multiple linear regressions. And then if there is a equation that has a non-linear form, how to convert it into a linear form and use a linear equation and a linear fit. So main objective of regression is you have a scattered data points and you want to know the trend in the data. You don't want to fill the data, you just want to know the trend in the data. Whereas in interpolation, the basic difference is you still have a scattered data points for variable x and y, but you know that it's from a continuous space. So there is one point in between that where you want to find the data, then you use an interpolation. So the given data set would be similar. What techniques are we going to use today can be applicable to the data set that I have given to you, we are taught or we came across in the last session. So those I will urge you all, so we will go through some questions today, and I'll urge you all to use the previous data set to solve using for interpolation. So data set doesn't matter, it's just a matter of what you want to do with the data set. So in the regression, yesterday I talked about how to quantify the fit of the data, right? So actually we didn't talk about it, we ended with the different regression models. And I said that in the start of the lectures, tomorrow's lecture, I will first tell you how to quantify your fit. So to do that, we'll just go back to yesterday's question. So yesterday we had this question where we use a linear regression, performed a linear regression fit for this model, right? And we use this fairly straightforward formula that we get by equating this by getting the slope of the sum of squared errors at a0 and a1 equating to 0, and rearranging those simultaneous linear equation, we got the formulas, and putting the values of it, we got to the value of a0 and a1, and we got this slope. This is your slope a0, and this point is your a1, right? So we got it till here, but how do you know is it a good fit or not? So that will start with today, and then we'll move on to interpolation. So what we are doing today is quantification of goodness of fit, or you can also say regression fit or linear regression fit or simple regression. So it is given by a term called R square. Okay, if you guys are going into the machine learning, they often talk about this, what is your R square value. If the R square value is somewhere near to 1, they say okay, your model is doing good. So this is basically R square. We will today study what is a basic funda or what is the basic concept behind it. So R square is also called as coefficient of determination. So in question paper they might ask you just what is coefficient of determination, that is called as R square. So R square is nothing but, so what we started with, what yesterday we were doing, we started with the error. So error, how we calculated, there are x values and there are y values, and we said that we will find a error between it. So error was y minus y hat, and y hat was our model that we are trying to fit. So y is a data set that you have given, y hat is the model that you are building, and using that model you are predicting the value. So this is also, y hat is your predicted value and y is your expected value. So this predicted value is given by this a0 plus a1x, okay. So this was there and we are using it, and then we said sum of squared errors we were doing for summation I is equal to 0. So we were squaring it up, right? Why? We were doing this yesterday. So this is a one way. So this is a one way to fit a model. So now what I'm saying you, rather than going for this doing, so you yesterday you saw it's fitting that y hat model is a pretty easy but lengthy process, right? So I would say I'll just take a mean of it, and if that is enough for me or not. So what I'm telling you, rather than y hat, I will use y bar, or it is a y mean. So rather than calculating the model, building a model, I'm using a y bar as my model, and that is given st, that is summation I, st, yeah. Summation I is equal to 0 to n y minus y bar. So what I am doing, rather than doing the, so I have these points, right, and I minimize this error. Rather than doing this, I am just taking the mean of it, mean of these y values, this y1, y2, if there are y3, y bar would be y1 plus y2 plus y3 divided by 3. I am just taking that and putting it here, okay, for each one, and some. So for this one, so if you expanded it, it would be y1 minus y bar plus y2 minus y bar plus y3 minus y bar, okay. That's what I am doing here. After getting this, I will try to find a efficiency of it. So what is efficiency? So that is what is your R square value. R square is nothing but your SE minus ST minus SE divided by your ST, this value. So how you will find ST and how you will find SE? SE is what? After, so you started with the X and Y data, okay, then you fitted one model, that is this model, you got this model. Now you have these X values, right? You put the X values here and you find what is the Y value. That is your, I will, just for the simplicity, I will call it as a Y model to keep you. So rather than calling it as a so okay, rather than calling it a Y model, this is a Y hat, right? So this is a Y hat. So those Y hat values you can calculate for each X value using your model, that Y hat you will have, okay. Then what you want SE, right? What is SE? Y minus Y hat. So here you will have a column Y minus Y hat. So you will subtract this from this from this, and take it square here. So because there is a square here, right? This is also squared, okay? This is also squared. So you will do that. And how you will find ST? Similarly, ST would be, you have this, there would be one more column first. There would be one more column Y. So you don't require a column here now, because you can just easily, what is mean? You will take a summation here, right? So you will have a summation here of this Y. So that this would be summation Y. And what would be Y mean? Y mean would be this summation Y divided by N. What would be your total N value, right? So if you have this summation, this value, you can just, so this is your Y mean value here. This is your Y mean value here. That value you will minus it from the each Y value here, and you will get this ST, Y minus Y bar, and take it square and get the whole set. And what, there is a summation at the end for a both, right? So you will sum it up. So at the end you have to again take a sum here. The summation will give you SE, this summation will give you ST. Now you have SC and ST at this block, then you can find R square is equal to SE minus ST minus SE divided by ST. So now, what is the value it is would be having a good fit? Can you just say from this formula? Can you tell me when it will have a good value? I mean, when your R square, if you get some R square value, then when you will say, okay, this is a good fit. So we have this ST, and this we have SE and ST. If your ST is equal to SE, it basically means that you are getting to you are putting one model, and you are getting the same value as the model which is given by Y bar, that is mean value. So rather than making a model, I would have just taken a mean of it. So your whole process is redundant. So if you get ST is equal to SE, then R square would be, so this would be 0, because ST minus SE will be 0, right? So this would be 0, right? And what is this? This is unnecessary labor, unnecessary use of your expenditure of your resources, your energy, because you have built one model which is basically similar to the mean of the what is your Y value that have been given to you. So your model is basically rubbish. So when the value is equal to 0, we say it is having a bad fit. And similarly, if your ST value, your R square value would be equal to 1, then it will be best fit. And when will be your R square value 1? When this SE will equal to be 0, right? So FC will be equal to 0 that time. Is your best fit. Okay, so you will get one value between 0 to 1. Okay, the number near to 1 is usually a good fit. A number farther from 1, let's say if you get a value somewhere around 0.9, 0.92, 0.95, okay, your fit is very nice. Otherwise, if it's somewhere around 0.56, 0.57 or 0.6, there is a chance that half of the points are farther away from your regression line and half of the points are very close. So error is very high at some point, so error are very low at some point. So I'll just show you through this Excel sheet for this one. So the screen is visible to you, right? The screen is visible? Okay, so maybe we have lost some students here. Okay, so what is happening here? What I have considered, there are x values and there are y values that we have started with. So I have plotted them here. You can see what we yesterday saw, our y-intercept was as a negative, and it is having a increasing trend. So our equation is correct. That is what negative slope, positive slope, and negative intercept. Now, what I was telling you, x and y value. Then we started with this. What I told you, we want to find out what is your this we got, this we had yesterday, x square and xy we had yesterday, and from that only we got this a1, and from a1 we got down to a0. Okay, today what we are doing, first we have to find out what is SE, right? So for that, SE is equal to summation of I is equal to 0 to n into bracket y minus y hat the whole square. Okay, so I need a y hat. So y hat is what? Your values of the values obtained using the model that you have built. So our model is what? A0 plus a1x. So a0 plus a1x, I am using a dollar sign to fixate it, and x I am calling it from here. So that is what I am doing for all the rows, and that's how I got this y hat value. Okay, but I just don't need a y hat. In the SE summation of in the sum of squared errors, we require a difference from the actual value, that is your y value, and take a square of it. So that's what I am doing it in this column. Okay, for each data point, and then I am summing it up here. Okay, this will give me SE. Now that is what is your SE. That is a one part of your R square. The other part is ST. You need a ST also, right? So for a ST, what I know, ST is given that other than building a model, I am saying I'll use a mean of it. So mean I can calculate by this summation y I have calculated here, and then I'll take divide by number of the data points, that is 4. That is I have done here. Okay, and I'm taking difference with the actual data point and take a square of it. That's what I have done here. The dollar sign is just to fixate the block. It will not change as I go down the table. So I have done it for all the data points, this y minus y mean the whole square, and took a summation of it that you get here. So this is basically your ST, and this is basically your SE. You get it? So from this I can easily calculate my R square. So R square is this ST minus SE divided by your ST, and I get to be 0.9697. So it is very closer to 1. So we can say that this is a very good fit, and we can use this model for our trend analysis or something. I'll tell you, this is a one way of doing it. Okay, one way of quantifying your fit for a linear regression. There are some data sets where even if your R square value is near to 1, it sometimes is not a good fit. So there is a one actual data set called NSCOMS data set. You can Google it, you can get it, and try doing this similar analysis, and try get to the R square value, and you will understand why I am doing it. And we'll talk about it if some of you have a doubt regarding that, why it does that, then we'll have a discussion on it. So it is NSCOMS data set. You will get easily, readily available on Google. So this is what I wanted to talk about your this thing. As what I was talking about, yeah, this was about the regression and the quantifying it. So we'll move on to the interpolation now. Okay, just give me a 1 second. So in interpolation, okay, so in interpolation we have discussed about, this professor discussed about 3 different methods. That is a Newton's forward difference, Lagrange's interpolation, Newton divided difference. Now, and direct method is also there, that I will briefly discuss with you what it is directly. So first is Newton's forward difference interpolation. So this first one, this can be used when your data set, so you have this x and y values, right? So if your data set, this x values x1, x2, x0, x1, x2, x3, if the difference between this is constant, then you can use a forward difference interpolation. This method only works when a difference, that is a h, is constant. H is what? x0 minus x1, that's it. The difference between this is constant. If you have a constant difference between the x values, then you can use the Newton's forward difference interpolation. Otherwise, you have to go for Lagrange interpolation or Newton's divided difference interpolation, where this x0, x1, x2, x3 values changes. So for instance, if your x value are 1, 2, 3, 4 or 10, 11, 12, 13, or let's say 100, 200, 300, or 100, 150, 200, 250. Are you get the idea? So difference need not be 1, it can be any difference, but it is a constant difference. So in that case only you can go for this one. If your x values are, I'm talking about, these are all x values for a different this. If your x value is having a something like 1, 3, 8, 14, so the difference is changing here, right? In that case you have to go for these 3. This one also works with this method also works with the difference h is equal to constant, but it's better if you know the difference is constant, you can directly use the forward difference because it is having a lesser calculations to do. So with that context we will start. So what is interpolation? Interpolation is so here I want to find a cubic polynomial which takes following values, and also find y of 4 and y dash of 4, okay, using Newton's forward difference formula, right? So what is I want to find out the value at this y dash of 4, right? So rather than doing this y dash of 4, so I will y of 2.5, y dash of 2.5, that we will find out. So this is a small difference. Why I am doing it? So basic interpolation means if you have some x, you are finding the value of interpolation means if you have some data set, for that data set you will find, let's say you x1, x2, x3, x4, you have 4 values. Those you will find a function of x at such a value which is in between x2, x1 to x4. In that case it is called as a interpolation. If it goes beyond it, means if the x1 value, if your x value that you are trying to find the function value is below your x0 and above your x4, then it is called as a extrapolation. So here if my this I had written the y of 4, so it is after this thing, right? That is called as a extrapolation. Basically you can use those formulas, the nothing else, you can extend same this thing, but in interpolation it is just such that x belongs to x0 comma xn, where n is your last this thing, right? So it should belong in between for interpolation. Now how to do it using forward difference? So forward difference, Newton's forward difference formula, if you know, it is given as y is equal to f of x is equal to y naught plus p into delta y naught plus p into p minus 1 divided by 2 factorial delta square y naught plus p into p minus 1, p minus 2, 3 factorial delta cube y naught plus p into p minus 1, p minus 2, p minus 3, 4 factorial delta 4 y naught plus so on. It will go till the infinity. Where to stop will depend on number of data points you have. So first we will construct our Newton forward difference table, and from the table you will only easily understand how to what is your stopping criteria. It is usually n minus 1. So we'll see what I'm talking about. So therefore Newton's forward difference table. So I'll just tell you how to go about it. First, this is your x. This is your x, this is your y. Okay. What are x? 0, 1, 2, 3. 0, 1, 2, 3. What is y? 1, 2, 1, 0. 1, 2, 1, 0. No, 1, 2, 1, 10. 1, 2, 1, 10. So delta y would be difference of these two. Delta y1 would be difference of these two. Delta y3 would be difference of these two. So delta y naught is equal to 2 minus 1, that is 1. Delta y1 is equal to 1 minus 2, that is equal to minus 1. And delta y2 is equal to 10 minus 1 is equal to 10 minus 1 is equal to 9. But if you see, we are only concerned with delta y naught. So we are only concerned with this value, right? Here also delta square y naught, delta cube y naught, delta raised to 4 y naught. So basically these values are of no use to us. These values are of no use to us. So you can only, what I will do is, I will delta square y. So here would be delta square y naught, right? So delta square y naught is minus 1 minus 1. This difference of these two. This is minus 2, right? And this I will not write as a delta square y1. I will just write 9 minus 1, that is 9 plus 1 is equal to 10. And this is delta cube y. Now delta cube y is this minus this. So delta cube y naught is equal to 10 minus, so 12. So this is your Newton's forward difference table. Now if you see, we have the value till delta cube, right? So we have to stop till here. That's what I was talking about. If you have a data points is equal to 4, n is equal to 4, there are 4 data points. In that case, you will have a polynomial of the order n minus 1, that is 3. So y is equal to, therefore using Newton's forward difference formula, y is equal to y naught. So this is your y naught, this is x naught, right? Y naught is 1 plus p into, so yeah, first we have to calculate what is p, right? So I didn't tell you how to calculate. So before going that, I'll just tell you. Here p is nothing but your x minus x naught divided by h. And what is x? X is equal to your this value, the value you are trying, x is equal, so x you will put at the end, you will not put it right now, you will just take a function call, like you know what is x naught and h. So h is nothing but this difference between these two. So we know, therefore h is 1 minus 0. So from the difference we know h is equal to 1, the constant difference, this is constant difference h, and x naught we know is 0, implies p is equal to x minus x divided by x minus 0 divided by 1 is equal to x. So p is x here for this data set. Okay, if your x naught value changes, you will, if your x naught value is equal to 7 maybe, and h is equal to, let's say the constant difference is 2. Let's say if you have a data set called as a x comma y starts with 7, 9, 13, 15. So the h value is 2, right? H value is 2 and x naught is 7. In that case, your p would be x minus 7 divided by, sorry, x minus 7 divided by 2. So that would be your P, and this x minus 7 you will substitute here, here, here. So right now it is just x. So what we have is y is equal to, so we have forward, so therefore using Newton's forward difference formula, y is equal to y naught is 1 plus p is your x into x minus 1, p into delta y naught, right? P into delta y naught. So delta y naught is 1 plus p into p minus 1. So x minus x minus x into x minus 1 divided by 2 into this minus 2 delta square y naught plus x into x minus 1 into x minus 2 into this delta cube y naught. So delta cube y naught is 12. So I'll write this down, x into x minus 1 divided by 2 into minus 2 plus x into x minus 1 into x minus 2 divided by 6 into 12. Right? So if you simplify it, you will get 2x cube minus 7x square plus 6x plus 1. That is your y. Okay, this is your y value. Now what you wanted to find, y of 2.5 and y dash of 2.5. So you also require y dash, right? So you just have to take a first derivative, that is 6x square minus 14x plus 6. Now therefore y of 2.5, so you will put 2.5 in this equation and get the value. So I'll just do it, 2 into 2.5 cube. So you get it, right? I'll just give you the final value. I'll just get my calculator. This is 3.5 and y is equal to, y dash of 2.5 is equal to 18.5. So this is how you get. So this is your interpolating in between value, and it is a value of the function slope that you wanted to find. So we use the Newton's forward difference. So why we could use Newton forward difference directly? Because in Newton forward, the crux of it is this h value. Without h value, you cannot find p. If you don't have p, you cannot use this forward difference formula. So for Newton forward difference formula to use, your x values should have a constant difference. Now we will move on to the next one, when there is a difference is not constant. Now if you see the x values here, in the first two there is 1, from 3 to 5 there is a difference of 2, 5 and 9 there is a difference of 4, 9 to 13 there is a difference of 4. So one or two values can have a age similar constant, but if you see throughout, there is a changing changing window size, or changing difference between your x values. In that case, your Newton difference formula fails. So in this case you have to use Lagrange's interpolation or any other, those three, anything you can do. For this data set I am showing you using a Lagrange interpolation. Okay, so how does Lagrange interpolation go? So Lagrange interpolation starts with, so Lagrange formula, interpolation formula is given as y is equal to, so y you want to find, you interpolating function, right? You want to find a function. So y is equal to L0 y0 plus L1 y1 plus L2 y2 plus L3 y3 plus so on. Okay, if you want to, so this is your basic equation. So here you have these values. At the start you have this y0, y1, y2, y3. This is your y1, this is your y0, y1, y2, y3, y4. Now you have to find what is L0, L1, L2, L3. This is given as a definition formula by Lagrange's. So these are Lagrange's constant that we want to find, and then plug this value here. So L0 is, so you are starting for a this thing 0, right? So how it goes at x minus x1 divided by x0 minus x1 into x minus x2 divided by x0 minus x2 into x minus, so here basically we have till x0, x1, x2, x3, x4. So we have to go till x4, right? So this is x2. Now we have x minus x3 divided by x0 minus x3 into x minus x4 divided by x0 minus x4. Okay, here you stop. If you had a further x5 value, you could have had x minus x5 divided by x0 minus x5. Since we don't have it, we will not consider it here. So where till what extent the this Lagrange constant formula goes depends on the number of data set. Okay, now L1, now we started for a 0, so we had a 0 here. Now what is x minus x0 divided by x1 minus x0, but now I will not have a x1 minus x1, I cannot have a, so here x1 minus x1 I cannot have, right? It will be undefined term. So here I will be just having x minus x2 divided by x1 minus x2 into x minus x3 divided by x1 minus x3 into x minus x4 divided by x1 minus x4. I guess by now you have got the idea. So here what we will have, x minus x0 divided by x2. So these two and these two, x0, x minus x2 divide, sorry, here I will have a 1, x minus x1 divided by x2 minus x1. Now I will skip x2, I'll directly go to the x3, x minus x3 divided by x2 minus x3 into x minus x4 divided by x2 minus x4. So you will basically have till L4, and those so this formula you will have till L4. Okay, so L3 would be x minus x0 divided by x2, x3, so this 3 and this 3, this one, okay, x3 minus x0 into x minus x1 divided by x3 minus x1 into x minus x2 divided by x3 minus x2 into x minus x4. I skipped x3, okay, x3 minus x4. Now for the last one, L4 is x minus x0 divided by x4 minus x0 into x minus x1 divided by x4 minus x1 into x minus x2 divided by x4 minus x2 into x minus x3 divided by x4 minus x3. So these are your L1, L2, L3, L4. So basically for again what is happening, for a data set having 5 data points, we are going for interpolating function with a order 4. Okay. So this is how you go for it. So here we want to find this L0, L1, L2, L3, L4 using these formulas. So what is x, what is x1? So your x1 would be x would be your this thing 9.3. What you want to find out, this is your x value 9.3. So 9.3 is in between here, 9.3, okay, somewhere in between. That is your x. X1 is your this x0, x1 is this, and from there you can calculate those values. So basically if you plug this 9.3 here and basically put those x1, x2, x3, x4, you will get the values as L0 is equal to minus 0.1301, L1 would be 0.2903, L2 would be minus 0.2658, L3 would be 1.0889. So I'll just repeat what I have done. We are doing Lagrange's interpolation because the difference between two data points is not constant. In Lagrange interpolation, the formula is y is equal to L0 y0 plus L1 y1 plus L2 y2 plus L3 y3 till the point which is till n minus 1. So here there are 5 data points, will go till L4 into y4. So basically here we will have till L4 into y4. Okay. So what are L0, L1, L2, L3, L4? So those values can be calculated using this formula. So the formula is easy to understand. We start with, for L0 we will give it into the denominator. So x minus x1, x minus x2, x minus x3, x minus x4. In denominator we will first have a term which is we are calculating for L0, x0 minus x1, x0 minus x2, x0 minus x3, x0 minus x4. So in L1 we will have the x1 here, for L2 we will have x2 here, we will have x3, L3, x3 here, and that term will be, so we will not do x3 minus x3 here or x2 minus x2 here. So that will basically make undefined term. So that we are checking out. So if you want to know the shorthand notation, this is y I is equal to sorry, y is equal to summation of I is equal to 1 to n minus 1 L I y I, right? This is your shorthand notation, and for the shorthand notation is L of I of x is equal to product of j going from 0 to n minus 1, okay, x of x minus j divided by xi minus xj. Okay, j is not equal to I, and I is also going from n to n minus 1. Okay, so this is the way you can find out. So right now you have got this L0, L1, L2, L3, and there should be L4 also, right? So I will write down what is L4. So L4 is your 0.0168. So if you plug these values L0, L1, L2, L3, L4 in this equation, you will get y is equal to minus 0.1301 into L0 into Y0. So Y0 is 1 plus L1 Y1. So 0.2903 into Y1 is 2 plus minus 0.2658 into Y3 is 6 plus 1.0889 into 10 plus 0.0168 into 40. So your y of 9.3 would be, you just do this, 9.799. So this is your final answer. So this is how you calculate your y of any value. So here you are basically what the value you are calculating for the x value, you will substitute it here. So this is your x value, I am telling again, and get down to the L0, L1, L2, L3, L4. Then you get these L0 values into the Lagrange interpolation summation formula, and then you will get the value. Okay. So this is a one way of doing it, a Lagrange interpolation, where it is changing continuously. Now again, if you have a data set where you want to have interpolation, then there is one other method called Newton's divided difference formula. So what is divided difference and what is so divided difference means here, so the different table will change and your equation also changes. So here you will see what is a Newton's divided difference formula, and then you will go for difference table. Again, at what extent it will go, it's usually n minus 1, and that you can also see it using a divided difference table. So that in first question we saw a simple Newton's difference table. Now it's a divided difference table. Okay. So Newton's divided difference formula. Again I will just saying okay, yeah, this 4 is in between, so 4 is somewhere here. Okay, so we want to find, so this is a interpolation, Newton's divide difference formula. So difference formula is y is equal to y naught plus x minus x naught into delta y naught plus x minus x naught into x minus x1 into delta square y naught plus, now here we have n is equal to 4, means order would be n minus 1, that is equal to 3. So we have to go to one more, x minus x naught into x minus x1 into x minus x2 divided by 2 factorial. So there is no factorial here, sorry, the x2, this is x minus x naught, x minus x1, x minus x2 into delta square y naught. Again if you see, we are only concerned with the starting value. So in the table also we are only focused on the data that are available at the top only, not at the bottom, only top values you will use. What is x again? X is your this 4 and x naught is this, x1 is this is x naught, x1, x2, x3 and this is your x. Okay, so we will see how to construct a Newton's divided difference. So this is its divided difference notation is like this. Okay, so it will have a divided difference, right? So only one delta, it's just normal difference, forward difference, and this is divided difference. So divided difference is denoted by this. Okay, so how to construct the, therefore Newton's table, Newton's divided difference table, right? So it will be x, y. Okay, we'll go as we move along. Okay, so x is what? 0, sorry for that, 0, 0, 2, 3, 6, 2, 3, 6. Then 648, 704, 729, 792. Okay, this is your y. So delta y, you know, so this is divided difference. So divided difference y naught would be, so this is x naught, this is y naught, this is x1, this is y1, x2, y2, x3, y3. Okay, so now what we want to do, delta for divided difference at divided difference at 0. So it's y1 minus y naught divided by x1 minus x naught. So here we are dividing with the these values. So it is 648 minus 704 sorry, 704 minus 648 divided by 2 minus 0. So basically you will get a value as 28. Similarly, this would be 729 minus 704 divided by 3 minus 2. Here it would be this minus this divided by this minus this. Okay. So 792 minus 729 divided by 6 minus 3. So here you will have 25 and this would be 21. Okay. Now it gets interesting. So in each term you will have to divide it with the respective x values. So how to find that x value? Now what we did here was, we are at this point now, we backtracked it. So formula became y1 minus y0, y1 minus y0, x1 minus x0. Similarly, if you backtracked it, what formula you got? y2 minus y1 divided by x2 minus x1. Okay, if you backtracked it, right? So this is the way you are going to do your divided difference. Now for the same logic we are going to use in second one. So delta square divided difference second one. So here it would be, right, delta square of y0 divided delta difference. So you are at this point na, so here and it will go here. You are at this point, right? So from here it will go here and then here. Okay, so your formula would become y2 minus y1 divided by x, y2 minus y0 divided by, so okay, I give you a, okay, so what you will have a first in the numerator you will have this difference of these two, right? So difference of these two will come in the numerator. So that is your delta y1 minus delta y0. Okay, and what will be in denominator? So if you see, it has gone here, so again you will backtrack it and this will go here, right? So here it would be x3 minus x0, x2 minus x0, x2 minus x0. Similarly, here you will have delta square of y1. So for delta square of y1, if you see, you will have in the numerator difference of these two, that is delta y2 minus delta y1, okay, divided by, you want to know what are the x, so what you will do, it will go like this, and here this one will go here and here. Okay, understood? So this is your x x3 minus x1. So if you plug in the values, you will get the value as -1, and this value would be again -1. Okay, so the final one, we also need a delta square, and this would be delta cube. Okay, this would be delta cube, right? Delta cube y naught. This is delta square was here, so delta square was here, so delta cube y naught divided difference. So again, delta here, what would be delta cube y naught would be equal to, now you basically have this thing, delta cube y naught. So you basically want to do difference of these two. So delta square y 1 minus delta square y naught divided by, now where it leads to you, and this would lead you. Okay, so this is x3 minus x0, and this, if you plug these two values and this value, that is -1 minus -1, this would be 0, right? And divided by anything, 6 minus 0, so this would be 0. So you are basically, because this is 0, you are basically, this whole term is going to be 0. You will have this 3, 1, 2 and 3 only. So we see what will happen now. So right now you have all the values for the formula. Y naught, you know, y naught is your this 648. X is nothing but the value 4, but we'll just keep x as it is for now, because we also want to find out the f dash of it. So first we'll find the normal function, then you will take a derivative of it, and then you will put the 4 at each point. Then x minus x0, x0 you have, x0 is 0, delta y naught is here, delta y naught is here, then delta square y naught is here, and delta cube y naught is here. It's 0, that is why this whole term is going to be cancelled. Okay, so therefore, using Newton's divided difference formula, what we have is y is equal to y naught is 648 plus x minus x naught is 0, so x into delta y naught is 28, and then x minus x naught, so x naught is 0, so again that is 0, so x into x minus x1 is 2, right? x1 is 2, so x minus x2 into x minus 2 into delta y naught, delta square y naught, that is -1, and the last term is 0. So if you simplify it, you will get 648 plus 28x minus x square plus 2x. Therefore, y is equal to minus x square plus 30x plus 648. Okay, now you have a function of x, that is a y value, y. Now you also want to find out the y dash of 4, right? So therefore y dash is equal to minus 2x plus 30. Now basically you want to find y of 4, so you will put a 4 in here. So minus 4 square plus 30 into 4 plus 648. This is 752, and y dash of 4 is equal to minus 2 into 4 plus 30. 30 minus 8 is 22. So this is how you find this interpolating function value using divided difference. Now Newton's difference formula can be used for this data set also. I would suggest you go for this and try solving it. Also divided difference formula can be used here. So try both and try to compare the results for your better understanding to gain more knowledge. Now this is what that has been taught in the class. So there is a one more method that just start at the start introduction lecture of this interpolation module. So taught it that was a using direct method. So in using direct method, what will happen? You will have a one equation. So direct method is, in question, you have the data set, right? You will have some data set x and y. You will have some data points x0, x1, x2, x3 at some day. Let's say you only have 4 data points x0, x1, x2, x3, x4, and similarly y0, y1, y2, y3, y4. Sorry, I'm going till y4. Then there is a 5 data sets. So if you have a 5 data sets, let's say I'll just write it down, x and y. I have x0, y0, x1, y1, x2, y2, x3, y3. So we have a 3 data points, n is equal to 4 data points, n is equal to 4. Then the order would be n minus 1, that is 3. You will have a polynomial of third order, that is a cubic polynomial. So if you have a 4 data set, 4 point, you can have a cubic polynomial. If you only have a 3 data point, you can have a quadratic polynomial. If you have a 5 data points, you will have a 4th order polynomial. You will also call it as a quartic polynomial, and so on. So that we can do. So for each x this value x0 value, you will can write down one equation, right? So how 4th order polynomial, so 4th order polynomial, how it is written, y is equal to a0 plus, so 1st order polynomial was a0 first. So what the model we were doing, we were using linear equation. So what we are doing, y is equal to a0 plus a1x. This was linear. So what is the second order? Y is equal to a0 plus a1x plus a2x square. That is second order or a quadratic. What would be cubic? Y is equal to a0 plus a1x plus a2x square plus a3x cube, right? This is your cubic. So if we have 4 data points, I can only do a cubic fit. So what I can do, I can start with writing this equation. For each x0, put it here, I can have I can have an equation for each x0. I will have an equation in terms of a0, a1, a2, a0, a1, a2, a3. So there would be how many? 4 simultaneous linear equations in 4 unknowns, that are a0, a1, a2, a3. Those are a0, a1, a2, a3. Those 4 unknowns and 4 simultaneous equation I can get, and then I will solve it using ax is equal to b, that we yesterday we were doing, right? So we'll just do it for this one. So for solution, the again what I have, x is equal to 0 2 3 6 0 2 3 6. So x is 0 2 3 6 and y is equal to 648 704 729 792. What I said? Direct method. So by direct method, y is equal to what? A naught. So we will use this function, right? Why we are using this function? Because there are only 4 data points. Since n is equal to 4, cubic fit is possible. Okay? Or a cubic interpolation. So what we will do is, first let x is equal to x naught, then what will be this equation fetch me? I becomes y naught is equal to x is equal to x naught, y is equal to y naught. Okay, y naught is equal to a naught plus a1 x naught plus a2 x naught square plus a3 x naught cube. So you have y naught value, you have x naught value. So y naught is 0. Sorry, y naught is 648. Therefore, 648 is equal to y a naught. You have to find a1. You don't know. X naught is 2, right? Into 2 plus a2 x naught square is 4 plus a3 2 square is 2 cube is 8. So you got one equation. Similarly, let x is equal to x1, y is equal to y1. So first equation will imply y1 is equal to a naught plus a1 x1 plus a2 x1 square plus a3 x1 cube. So y naught is what? Y naught is 704. Y naught. So y0, y1, y2, y3, x0, x1, x2, x3. So 704 is equal to a naught. You want to find a1 into x1. X1 is x naught is 0, right? X naught is 0. So this will be multiplied by 0 only. Sorry, so this is a1 into 0 0 0. So this whole term will get cancelled out. So this 648, this is your first equation. Okay, now x1 is 2. X1 is 2, right? So 2 plus a2 into 4 plus a3 into 8. So this is your second equation. Let now x is equal to x2, y is equal to y2. So therefore y2 would be a naught plus a2x, a naught plus a1 x1 x2 plus a1 x2 square plus a3 x2 cube. So what is y2? Y2 is 729 is equal to what is x? X2 is equal to 3. Okay, a naught plus a1 into 3 plus a1 into 3 square, that is 9, and a3 8 sorry this is 3 cube, that is 27. And finally let x is equal to x3. So this is your final equation. X is equal to x3, therefore y3 is equal to a0 plus a1 x3 plus a1 x3 square plus a1 x3 cube. So this is 792, I guess 792, and x3 is 6. So a0 again same, a1 into 6 plus a1 into 36 plus a1 into 36 into 6, this is it's 216. So if you see, this is your fourth. So if you see, a0 a1 sorry this is a2, right? It has to be mistake. Even a2 a3. So this is a1 a2 a0 a1 a2 a3 a0 a1 a2 a3 a0 a1 a2 a3 a0 a1 a2 a3. So if you see, these are simultaneous linear equation in unknown that are a0 a1 a2 a3 with the rest of things as a coefficient. So these are 4 equations in 4 unknown simultaneous linear equations. You can find out a0 a1 a2 a3. So how to do that? Again, this last similarly that what we did in the last class. So you can write it as ax is equal to b, right, where x is equal to your this thing, right? So what will be your a will be, so you can write it as this thing, that what I'm saying. So your coefficient matrix 1, so for this thing there is only a0, right? So a would be 1 0 0 0, then from second 1 1 1 2 4 8, right? One, 2, 4, 8, then 1 3 9 27, 1 3 9 27, 1 6 36 216, 1 6 36 216 into a0 a1 a2 a3 is equal to b is your these values 648 704 729 792, 640 y values 648 704 792 sorry 729 792. Okay, so now you can easily straightforward you can do, you have to take these equations. So how you were finding out, is equal to A transpose A inverse into A transpose into B, right? Now yesterday I didn't tell you, I just hope that somebody would tell me, but there is a one formula, there is a one manipulation when the case is when the A is having a n by n matrix. So if A is n by n matrix, then we can simplify this further. We can write it as A inverse into A transpose inverse into A transpose into B. So we simplified it like this. So this will cancel each other out. Okay, the inverse into this is equal to 1. So it is cancelling, means it is an identity matrix. Identity matrix is 1. So this will lead to I. Okay, and I multiplied with anything, it will not change this thing. So you can directly write it as A inverse into B. So basically what you want to do, you have to take an inverse of this matrix and multiply it with this matrix, you will get this matrix. So this is your A, this is your this thing, and this is your B. So you basically want to take an inverse of A, multiply with B, you will get A0, A1, A2, A3. So how to take an inverse 4 by 4 matrix? You can do it in this calculator. If you go in this matrix and then there is this matrix, this thing, then you will have option to define the matrix. You will just select that, then it will ask you how many number of rows, you will tell 4, how many number of columns, you will tell 4, and then it gives you one setup with the matrix, 4 by 4 matrix, where you have to fill in your data. So I'll just fill in for you guys. 0 0 0 1 2 4 8 1 3 9 27 1 6 36 2 1 6. So I have filled this data and it is at a matrix A, mat A, if you can see at the top left corner, right? It's at a matrix A. So if you select this thing, now if you want to call it from the calculator, how you will do this? You will go into the option setting, and at option you can, if you press the option button, you will get this matrix A, mat A. So if you select mat A is at the third number, right? So you just press a third, then you will get this matrix A into, so if you want to take the inverse, just take this x raised to minus 1 is the key is there, right? And that will fetch you the inverse of the matrix. So that's how you do it. So this is your A, this thing, matrix inverse, and if you multiplied with the B, so I will just write down. So okay, fine, I'll just write down what is the A inverse that I have gone. So 1 0 0 0 minus 1 2.25 minus 1.333 0.0833 0.3055 minus 1.25 0.8888 minus 0.069 minus 0.027 0.125 minus 0.111 0.10138. Okay, and you have B, that is your Y, right? Y0, Y1, Y2, Y3, 648 into sorry. So this is 648. So this is 648 704 729792. Okay, if you multiply it you will get the A, that is A0, A1, A2, A3. So that is your 648, 30, minus 1, 0. So this is your, if you, what was your starting equation was, y is equal to a0 plus a1x plus a2x square plus a3 x cube. So if you plug these values here, you will get the final equation. A0 plus a1 is 30x. See, this is a0, a1, a2, a3, right? So 648 plus 30x minus x square is 0. If you compare it with the last question, so what equation that we had got using the this thing, 648 plus 30x minus x square. So the similar thing we had got here. So this is how you can also use a direct method. Direct methods sometimes will not give you a correct result. It depends on the data set also. So you can use direct method or this thing, Newton's forward difference table when the data set is more high. So what the problem is, as you go with the higher dimension, higher number of data set, so this direct method will not sometime work. So with this, let's conclude today's session. If anyone can have doubt, just say you can raise your hand or something. You can write also. Okay, let's conclude today's session. So by now we have concluded till week 7, interpolation and regression fit is done. Next week there will be no live session. These sessions will be uploaded in due course of time, and we will directly meet in the week after next one. Thank you. क्या हुआ? खत्म